Hello. Okay. I think we can start our class today. Uh, I already bought the slide on e-learning for you, so you can go to e-learning and then download the slide for this week. Okay. Okay. And this week we go to another module. We call this is the ad detections. Ad detections. Okay. So so what is the ad? So here. Okay. So what is the ad detection? So briefly speaking, ad detection is this one. Example, I give you this image, and then what is the ad in the image? In the image. Okay, so in the image, you can see that there are some continuous line like this, right? Continuous line. Okay, okay. So the edge can appear at the boundary of the object inside the image, or the edge appear inside the image, like this. Example like this. Okay. So edge is one of feature of the image. Okay. And if there are if I give you this picture, and if you think that okay, edge detection. So if we are human, so we will think that okay, edge detection. So that we will extract the continuous line like this, Okay, but in the computer or image processing, edge detection is some kind slightly different. So in image processing, edge detection is to find the continuous line in the image, all the continuous line in the image. Example here, this is the continuous line at the border of the tiger, right? The tiger, but there are still some continuous line inside the tiger. So in the image processing, they will also find the line, the continuous line inside like this. Okay. So what will cause the edge? So there are some factor to determine this is the edge. The surface normal discontinuity, the depth discontinuous, the surface color discontinuous, then illumination discontinuous. So here you can see that they are discontinuous and discontinuous, right? So when we meet the discontinuous of surface depth, surface color, or illumination, we will have the edge. Example here, right? Example, we have the light, right? Some light project on the bottle like this, right? Right? And we have the shadow, right? We have the shadow, and this one is the illumination discontinuous. Why? Because here is have the another how to say intensity, right? This one have another intensity. So when we come from outside in to inside, right? They are discontinuous here like this. So at the boundary they will have the edge like this. Okay. So by researching, we know that there are 4 types to form the discontinuous. One is the step. What is the step? Example is the white color, right? And this is black color, right? Suddenly change. So at this one they also have the step, and this one called the RAM. So example, this is white color and this is black color, right? It changed the color from white to black, but not suddenly, right? Just change like the function, right? Linear function. Okay. Another is the roof. They also cause the edge, and also the spine like this. Okay, so let's look at the example here. When we look at the example, right, when we zoom here, and we zoom here, and we have at this picture, right, and here you can see that there this continuous of the color, right, the color. This is white, right, this is darker, and this is darker, right. So this is like the RAM, right, RAM, right. Okay, and here, right, and here is from here, right, you can see that this will form the edge here, right, the edge will happen here, okay. So this is how the edge to be formed. Okay, so let's go to the more detail example. At the edge, we at the image, we have this image. Okay, and here example, if we have the line go from left to right, and we read the intensity here, so the intensity will perform like this, right. It's the right white pixel, right, and then the dark, right, dark, and then dark, and then white, right, white, and then white, right. Okay, so this one is like the intensity, right, intensity. But if we use this one to determine where EDS, it is a little difficult because many noise here, so this one like the RAM here, so it's very difficult, because the continuous is rapidly, so we don't know. So normally we use the first derivative. So when we do the derivative of the image, they will have the form like this. As at the edge here, they will have the peak value. Will have the peak value, right? Negative peak value, and this one we have the positive peak value. So from this one we know that okay, there are two edge here, Okay. So normally we will recognize the edge by the first derivative. Okay. So what is the image derivative? I hope that you already do the exercise about we call it the Sobel, right? Sobel filter. Okay. Sobel filter. This is a kernel, right? A kernel. So this one, when you apply the kernel on the image, that means you do the image derivative. Why? Okay, let's see. Okay, so if we have the function, right? If we do the first derivative, it will become like this, right? And generally we have this function, right? So what is it? This is example. This is the intensity of the previous pixel, and this is the next pixel. Okay. So the first, what is the derivative? The derivative. This is the changing, right? The changing of the past and the current, right? Or the past, current, and the future, right? So this is the derivative. So when we apply the mass like this, okay. So that means what is it? You let the let's say this is the mass, right? The past pixel, right? And the current pixel, right? And the future, right? The future. So when we apply the mass like this, is it you let the future the minus the past, right? So this is the derivative, right? This is the derivative, right? And the result you set at the current. So is it the derivative? Yeah, this is the derivative because it changed from the future and the past. This is the derivative, right? Okay, so this is the first derivative. First derivative. And normally in the first derivative, there is a lot of noise. You cannot ignore, you cannot solve. So they will use the second derivative. Second derivative. So here you can see f dot is here, right? F2 dot here, right? So that means we have this function. And then apply s equal to 1 here, you have this one. Equal this one. Okay, so this one, right? This one is your Sobel mass here. Your Sobel mass here. Your Sobel. This one is 1 pixel, right? So if we use the mass 3 by 3, right? 3 by 3 is 1 minus 2, right? 1, right? And 0, 0, 0, right? 1 minus 2, 1. Is it? Yeah. This is the mass 3 by 3, right? This is the mass 1 by 3, right? Okay. So example, this is 3 by 3, but first derivative, what is it? So example here, right? We can see that this is 255 and this is 10, right? This is 10. So there will be the S happen here. The S happen here, right? So we apply the mass, and then we have this one. Here we have this one. And then this one is for the horizontal. Why for the horizontal? Okay, we have this one. Okay. So this one we can call this is we apply the mask on the image. All right. Okay. So actually the I say the equation of the mass is derived based on this one. Example, this one is the Z1, Z2, Z3, and Z9, right? And we have the robot at detector is this one. That means you just let Z6 minus Z5 and then Z5 minus ZA. This is the robot at detector. And if you apply this equation with C equal to 1, you have the pre-quit at detector, and C equal to 2, you have the Sobel at detector. Yeah, the Sobel at detector. So that means the Sobel mass, pre-quit mass, right, is obtained by this equation, right, by this equation. Okay. So now you already know where is the Sobel mass, what is the Sobel mass, right? Why the number here is minus 1, minus 2, and minus 1 here, right? So this is the reason. Okay, so this is the summary of it. Example, you have the mass 3 by 3, right? Mass 3 by 3. And from this one, right, if we apply the equation, and then we have the robot, and then pre-quit, robot here, pre-quit here, and then Sobel here, right? Okay, so but here you can see that if you just apply this one, you can see that here you will find the S here, but the Y of it, the width, right? The width bigger than 1 pixel, right? If example here is 2 pixel, right? 2 pixel, right? 2 pixel. So in the edge detection, we want this one become just 1 pixel, 1 pixel, 1 pixel. right? So to make it become 1 pixel, we have some more definition. First, this is image radian, image radian, image radian. So what is it? So the image radian is this equation, this equation. So the radian, image radian. That's the this is the vector, the vector. Okay, the vector, and then this is the origin. Origin of the vector is a s x and y, x and y. Origin at x and y, or u and v, or u and v, and chain directions. The chain directions e theta, chain direction e theta. So if we have the vector, right? If we have the vector, we must have the origin, right? Origin, and then the magnitude, right? And the direction, right? So this one is for you to calculate. This one is the magnitude, and this one is the directions, in the direction. So based on the directions and the magnitude of the image radian, we can reduce the width of the pixel. We can reduce the width of the pixel. How can it reduce? Okay, let's go. First, this is the real example. First example, we have the noisy input image like this. Why this is noisy? Here you can see that at this one, right? A lot of noise. Not beautiful like this. 0 and 255. No, right? A lot and a lot here. A lot and a lot value here. So when we scan like this, we will have the equation like this. The pixel here, right? Pixel here, and then this row like this. Okay, row like this. Okay, and then if we take the first derivative of the image, because the derivative is the changing, right? The changing of the current and the bus, right? So here example here, right? You can see that if we change like this, loss, and from here you cannot see where is the peak, to determine this is the f, right? So we cannot determine. So before we apply the f detection, we often convolution with the kernel Gaussian. We define a Gaussian kernel, and then we do the convolution. This one convolution with this one, and when we do the convolution, this one will become very smooth like this. All the noise here becomes zero, and this will become the linear motion like this, Okay, and then we do the first derivative of the result here, and here you can see that you can find one peak here, and from this one you can see that okay, at the position 1000 you have one f here, one f here. Okay, so this is the procedure, the first step. Okay, and we have some remark here. From the mathematics, this equation will equal to this equation. So let's have some remark here. Example, the Gaussian kernel is 3 by 3, right? Example like this, 3 by 3 or 5 by 5, right? It is very small, right? And you do the derivative of just very small kernel here, small size here. It is very fast, very fast. Here you can see that you do the derivative of the very big image, very big size image. So this one very slow, very slow. Okay, so normally because the equation are equal, so they will use this one to perform. So let's rewrite the function. Example, we have the image, noisy image here, right? So instead of we define the kernel and then convolution with this one, right? Convolution. This one. We derivative the kernel first. Okay. So when you derivative the kernel, you have this one. You have this chef. And then you do the convolution. So the result is the same of the previous one. But this one is very faster than the previous equation. Okay. So this is the remark for you. Okay. And this is the effect of the derivative of the Gaussian kernel. This is the effect. Okay. So I skip this one. Okay. So in the Sobel filter, right? In your exercise, yeah, you already did something like the Sobel, right? Sobel filter. So what is it? We apply the filter on the U, right? On the U direction, right? And this is the U direction, and this is the V direction, right? So you apply the Sobel filter for the U direction, you have EU. And for the V direction, you have EV, right? IV. And then you do the this math. So this one will equal to I here. This one is the matrix. So when you display the I here, display this one. This one is this one. Okay. And this one. Okay. So when you apply the Sobel, I'll say the Y right here, right, is very big, right? It's very big. So to reduce it, you have to apply step 3 and step 4. This one is step 1 and step 2. You already did. Now you will perform the step 3 and step 4. Step 3, we call this is the non-maximal suppression. The result of step 2 is that you already have the S here, but it is very big. The Y, the Y here is very big. So we apply non-maximal suppression. Okay, so what is it? Okay, this is the non-maximal suppression. Briefly speaking, when you finish the step 2, you have this one. You have the S here, the S like this. Okay, the S like this. So to reduce it to smaller or 1 pixel, they will choose like this. They choose 1 pixel on the edge. They choose the 1 pixel on the edge, and then from the direction of it, right? They will choose 3 neighbor of this point, and then they choose if example this one have intensity 100, magnitude 100, this one have the magnitude 105, and this one have the magnitude 110. So they will choose 110 and then let the remaining become 0. This one become 0 and 0, and this one become 110. So this is the non-maximal suppression. Okay, so this is the procedure. So, and this is the equation, and this is the equations. This is the equation. So later I will give you the example for clearer, for clearer. Okay, so we have one problem in non-maximal suppression, because in non-maximal suppression we have to apply the magnitude and the direction, theta, 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 theta. But when you do the theta, theta like you have the theta matrix, and the theta here they have many and many angle. Example theta, they have example 1 degree, 2 degree, something like this here. 1, 2, and 3 degree, and this is 10 degree. This is degree, okay, and this is 15, and this is 120, something like that. Okay, so because of we have many and many theta here, they will how say collect it, zip it into just 4 degree, 4 degree like this, like the bin, 4 bin, into 4 bin, 4 bin. Bin 1 is 0 degree, bin 2 is 40 and 90 and 135. So how to zip it into the bin? So this is the equation. If you calculate the theta, if the range from 0 to 22.5 and 150.5 to 180, it will consider that this is the bin 0, so 0 degree. So here 0 degree, it is just 0 degree, and so on. The range is 45 degree. So this one and this one is 45 degree. From this one and this degree is 45 degree. That means from this range, they will consider, let's say, 45 degree. Okay, so that means we will reduce, right? Reduce it into the 4 pin like this. Okay, so, and this is the code, example code for reduce the pin, reduce into the pin. Okay, okay, so we will do the non-maximal suppression like this. This is the code for the non-maximal suppression. You can refer on the slide. Okay, oh, where is it? Okay, okay, so after this step, after this step, you already have the edge 1 pixel, but it's the still have problem. It is still have problem because this one, the non-maximal suppression, just give you the local maxima. So to finish or to make it complete, we will have to do the heuristic thresholding. So what is it? What is the heuristic thresholding? Here is, this is the equation of heuristic thresholding. When we do the heuristic thresholding, we will meet the situation like this. This is the threshold, right? So we will have 2 threshold, max value and mean value. Okay, so from this one we have 3 case. 1K, this one is bigger than max value, 1K is between, and 1K is smaller than mean value. Okay, so after you have the non-maximal suppression example, you have the matrix of non-maximal suppression. You will scan is again, we scan it is again. Example, you scan it at this point, at this point, at this position, at this position. Okay, and then you have to check the magnitude. You have to check the magnitude. If the intensity bigger than max value, it will become 255. Become 255. Smaller than mean value, it will become 0. If it fall into between like this, between like this, between like this. So if it fall into this case, you have to check a nearby point, a nearby point, a nearby point. So they compare current pixel with a nearby point pixel. If the intensity of the current, this one, bigger than OA, bigger than OA, related to the max value, so it will become the maximum. Maximum. Okay. Okay. So this one, it's connected to an X pixel. That means connected to the highest value, max value. Okay. So let's do the example for you. This is the code for do the hydroelectric thresholding. Okay. Okay. So this is the summarized procedure for you in the canny X detection. First, Gaussian kernel. Gaussian kernel. Next is to calculate this one, magnitude and the directions, and then zip it into the pin. Zip it into the pin 0, 45, like this. Okay, and then do the non-maxima suppression. Do the non-maxima suppression, and then do the hydroelectric thresholding. Okay, example. Example, you have this image, and then you do the canny X detection. So what is the procedure? First, apply the Sobel, right? Sobel. When you do the convolution, you have this one. You want to have this one. And then what is it? And then calculate magnitude, right? And then direction. And this is the magnitude, and this is the direction. The magnitude is this one. Let's see. Why this is 42, right? Here. Can you do this? 30 square plus 30 square, right? Is it 42? Yeah, 30 square, 30 square. Right, here. Like this, here. And then you do the remaining. You do the remaining. Okay, and here it is the direction matrix. Direction matrix. Here, what is it? Why is it 45? Why? Easy. Theta equal to tangent, right? This one and this one, right? 30 divide 30, right? So is it 45 degree? Yeah, it is 45 degree. Okay, so this one is 45 degree. Then you do the remaining. And then apply the equation here to zip it into this one. And after this step, you have this one. This is the direction. This is direction 45. 45, right? Zip into it. Okay. And then you do the non-maxima suppression, right? Non-maxima suppression. Okay, so how to do it? How to do it? Okay, let's see. What is the non-maxima suppression? Okay. The first is this point, right? We scan one by one, right? From the top to the bottom, right? First one is this position. This position. This position have the 45 degree, right? 45 degree. So from this one, you draw a line like this, 45 degree, right? And choose. From this one, right? You can see that which value. This one, right? Example, you do the betting here. Example. So you have three value, 0, 42.4, right? And 4.2, right? So which value is marked is biggest? Of course, this one, right? So you keep this one. You keep this one. Keep this one. And the remaining 4.2, right? Become 0. 0. Okay. So this is non-maximum suppression. Okay, let's do another. And then we do next one, 50, right? 50. Okay. 50. Let's see. 50. This is, what is it? 90 degree, right? 90 degree. Like this. Okay. This one is 50, 90 degree, right? Is there any 50 degree here? 90 degree here? On this line, is there any 90 degree? No, right? No 90 degree. So just only one. So we skip it. Just only one. We skip it. Okay. How about this one? Example, this position. This position is, what is it? What is it? Oh, sorry, this one is 0, right? Sorry. This one is 90 degree, right? 90 degree. And from this one, we draw a line, 90 degree. 90 degree, right? We draw a line, 90 degree. And then from here, you can see that which value is biggest. Which value? This is 90 degree, right? This is 90 degree, okay? Which one is biggest? I'll call this one, right? So this one is keep, right? Two remaining become 0 and 0, right? Here, 0 and 0. So this is non-maximum suppression, okay? Okay, and then after this non-maximum suppression, you have this one. You have this one. And then from here, you apply the heuristic thresholding, right? Heuristic. And this one is the high value and low value is the this one become 1. Okay. Yeah. Okay. If you don't have, we go to the next one. More detail. Okay, this is the exercise for you. Example, I give you this one. So we will apply 4 steps to do the canny F detection. Okay. First is filter, right? Filter by Gaussian kernel, right? So we define the Gaussian kernel 3 by 3. If sigma equal to 1 like this, and then we have this one. This one is the Gaussian, right? Gaussian kernel. And then we apply this one into the image, right? Convolution with the image, right? Okay, so here we can see that we betting the image because we want to calculate the border. We still want to calculate the border, so we betting it. Okay, so we betting it and then apply the filter on this one. So after we convolution, we have this image. Okay, after convolution, we have this image. And then the second step is Sobel, right? Sobel. So we apply the Sobel on the X direction and Y directions. Okay, right. And then we apply step by step here into here, right? After this step, we will have two matrix, Gx and Gy, like this. And then what we calculate next? Radian matrix, right? Magnitude, right? And then direction, right? Direction, right? So just square this one and square this one, right? And then do the math, right? And then square, right? And then we have the matrix G and the orientation, right? Orientation. Orientation. Okay, from this one, what is the next? Because the orientation have so many angle, right? Have many angle. So we will zip it, right, into bin, right? Zip it into bin. And then we choose the bin like this. 0, 45, 90, and 135. So after we apply this one, we will have the S direction like this. Okay, S direction like this. And then the next one is to apply the non-maxima suppression, right? Non-maxima suppression. So let's see. Let me copy the directions here. Wait, it is saving. Yeah. Okay, let me do. Okay, we have the radian magnitude, right? And then we will do the non-maxima suppression on it. Okay, so the first A we will this is the betting, right? Betting, right? Betting, right? So we will use 3 by 3, the window 3 by 3, right? And then we have this one, right? And at this point, what is the degree? 45 degree, right? 45 degree. So from this one, you can see that you check on the 45 degree. So here you can see that when you check the 45 degree. So what is the result? This one is biggest, right? This one is biggest, right? Biggest. So if this one is biggest, sorry, this is 0 or still 0 here. Sorry. This one is still 0. Here, this one is still 0. We choose this one, right? This one, because this is 3 by 3, right? 3 by 3. So this one it become this one, right? Oh, sorry. No. This one is this one, 3 by 3. 3 by 3. So this one become this one, okay? And this one is 45 degree. This one is 45 degree, right? 45 degree, right? So from here, you can see that 45 degree. And then this one is bigger than this one, right? So this one become here. And this one become 0, right? Become 0. Okay. Okay, and let's go to the next one. Let's go to the next one. The next position here is 90 degree. This is this number, 90 degree. Okay, 90 degree. So let's see. This is 90 degree, and then this is 90 degree, like this, 90 degree. So from here, right, you can see that you have the number here. This is 90 degree. Here you can see that 90 degree. This one is biggest, right? This one is biggest. So this one we is still keep here, right? And this 271 will become 0. Will become 0. Again, become 0. Still keep it. Still keep it. And then do the step by step. You will have this result. The result like this. The result like this. We have the result like this. We have the result like this. Okay. We have the result like this. Okay, and the next one is do the max and mean value. Heuristic thresholding. Heuristic. Okay, so in the heuristic here, I will copy the result of the last one. Okay, this is the result of the last step, and we have this matrix. We have this matrix, right? And then you choose the heuristic thresholding. Max value is this value, and low value is this value. So bigger than 760, it will become 255. So this one will become 0, right? This one, oh, sorry. This one is, sorry. Okay. Let's see. This number is bigger than 600 and 760, right? So it's become 255. Okay, 255. This one is 255. Okay. This one they have the column here, right? Yeah. Okay. So this one become 255 here, right? And this one, this number bigger become 255, right? This one bigger than become 255, right? So the first is choose which number bigger than 760, right? And then which one is smaller than 700? Which one is smaller? So the remaining, right? The remaining. Example, this one. This one is smaller, right? This one is smaller, right? Okay. This one is smaller. Okay. The remaining, right? The remaining. And then which number bigger than 700 and smaller than 760? Which number? Is it this one? Is it this one? Okay. So after this step, this number is still don't know. It's still don't know. It's still don't know. Okay. This one also is still don't know, right? It's still don't know. So let's see. At this point, right? We check with a point nearby. A point nearby, right? A point nearby. So it's connected to this value 800, 804, because this one bigger than max value, bigger than max value. So we keep it. So this one keep it, and 255. How about this one? How about this one? How about this one? How about this one? This number. This number. This number. Is it this one? Yeah. It satisfies this condition, right? So check a point nearby. A point nearby, right? A point, right? So here is connected to this one. So keep it 255. Keep it 255. Okay, and how about this one? This one. This one. How about this one? This value. It satisfies this one, right? Bigger than 700, right? But smaller than this one, right? And then check A boy nearby. A boy nearby. So the is connected to any max value? No, right? No. Don't connect to any max value. So it will become 0. Okay. So this is the heterogeneous thresholding. So this is the procedure. This is the procedure of canny detection. So this one is the programming. This is the programming. This is the programming. So okay. And in OpenCV, they have a function like we call the canny detection. Canny like this, right? And very easy. Just apply this function. They will do all the mathematics and all the problem we already discussed. Just apply this function. And when you apply this function and do the manual, it will give you similar value. Okay. So this is the canny detection. Okay, so do you have any questions on this one? No? Okay, so I know that when I explain to you, it's still it make you how to say confusing, right? But I think that after the class, you watch the movie and then redo the example. I think that you will clearer. You will how to say understand more, understand clearer. Okay, this is just apply 4 steps like this: step 1, step 2, step 3, and step 4, right? And then this is the canny edge detection. Okay, so do you have any questions? Okay, if you don't have any question, I have a small problem here. Let's discuss. Okay, let's assemble this one. Let's do the non-maxima suppression and hydrostatic rest holding. Example, I give you the radiant magnitude, the magnitude of the matrix, and the direction matrix, and magnitude matrix like this. Do the non-maxima suppression. Do non-maxima suppression. Okay, let's see. You have this one. Okay. First, this point, right? This point have the oh sorry, this point, right? And this is the theta. Sorry, this is theta, right? Theta. So this point have the theta is 135 degree. Okay. So do the non-maxima suppression, right? 135 is this one, right? In this direction, right? On this direction. On this direction. Oh, yeah. This direction, right? So on this direction, this one is biggest, right? This one is biggest because this is just 0, 0, and 0, right? 0 and 0. So keep it. Keep it. Okay. And this one is 45, right? 45 and 45. So this one is this one. So because this one is bigger than this one, so this one becomes 0. Keep this one. Okay. And how about this one? This one. This one is 45, right? 45, right? And on this direction, just only one 45. Right? Just only 145. So keep it. And how about this one? 90. 90. 90. Okay. 90. This is it this one? Right? Is it? So this one 90, 90, and 90, right? Similar, right? Similar direction, right? And from this one we have three value. Three value. So this one is biggest, right? So keep it. And 2 remaining become 0, right? This one becomes 0 and this one becomes 0. Okay. This one is similar. This one is similar, right? Okay. So just apply this and then you have this one. And then after that, you do the hydrostatic rest holding. Hydrostatic. And high this one and low this one, right? So the question is how to choose the high value and low value. It depends on you, depend on the experiment. Right? Just trial and error. Just trial and error. And then here, right? If bigger, sorry, this is smaller, right? Smaller than low value, right? So it becomes 0. Becomes 0, right? Becomes 0, right? This one also smaller becomes 0, right? This one is bigger than high value, right? So it's become 1, right? It's become 1, right? And which one is in between? Which number is in between? Let me see which number in between. This number. This number. Is it? Yeah, this number, right? This number. So this number in between, we will check. We will check a neighbor boy 1, 2, 3, 4, 5, 6, 7, and 8, right? So when we check the neighbor, when we check the neighbor, it connect to this one. Oh, related. We have the neighbor very strong here. We have the neighbor very strong. So we are strong. Okay, so become one. One. Okay. Okay, so this is the hydrostatic holding. Okay. So do you have any question on this one?
No.
No?
Can you explain again the non-maximal expression?
Okay, I will explain again. To do the non-maximal suppression, right, we must have the magnitude matrix, right? The magnitude matrix and the direction matrix, right? This is the direction, okay? Direction matrix. Okay. So to do this one, right? We will check scan, right? Each position, right? Just position. So the fourth position is this one, okay? The fourth position. So let's see, this position have the, what is it? 135, right? 135. So 135 is it this we have some problem on the internet. Okay. So oh, okay. So do you still have any more questions on this one?
I don't hear anything when you disconnect.
Okay, so let me explain again this one. Okay. Okay. So
Teacher, you haven't shown the screen yet.
oh yeah, sorry. Okay. Okay, so let me explain again. Okay, let me explain again. Okay, to do the non-maximal suppression, right? We must have the how to say, the magnitude matrix, right? And the direction matrix, theta matrix. Okay, so let's do the first point, the first position. This one, this position. So on this position, we have the direction is 135, right? 135. So we draw a line 135. And on this line, right, just one point have the number 135. So they are pickets. So we keep it number. We keep the number. Okay. And then the next one is this one, this point. Okay, this point, this point. So this point have how many degree? 45 degree, right? So on 45 degree, this one is this direction, right? 45 degree. And on this line, we have 2 points, right? This point and this point, right? So we compare the magnitude. So when we compare the magnitude, this one is bigger, right? So this one we keep it, and this one we let it 0. So this is the non-maximal suppression. Okay. Okay. And then this point is similar, and we go to this point. Okay. So on this point, what is the angle? 90 degree, right? 90 degree. Okay. So this is 90 degree. I cannot. Okay, this is a 90 degree. Okay. This is 90 degree because we do the bedding. We do the bedding. This is 0, 0, 0, 0, right? 0. So we will compare 3 points. This point, right? This point and the left and the right. We still have 190 here. We don't care about this. Later we will care. Okay. Just care about 3 nearest 3 points. This point and then the left. Sorry, this point, the left and the right. Okay. So that means we will have number 0, 152 and 670, right? So we compare 3 value. So of course this one is biggest, right? Biggest. So this one will become this one, right? The 2 remaining become 0. This one becomes 0, right? One becomes 0. Okay, so this is the non-maximal suppression. So is it clear? Anything
Yes.
unclear?
Yes, it's clear.
It's clear. Okay. And then after you have this matrix, you just do the hydrostatic thresholding, and then you have this one. Okay. Okay. So let's see about the canny detection. Okay, so if you don't have any more question, we can stop now. We can stop now. Okay.
Thầy ơi cho em hỏi cái điểm nhóm á thầy. Thì bữa trước nhóm 3 bọn em đã trình bày lại là bọn em có nạp lại bài cho khác á thầy. Mà sao thầy vẫn để điểm 3 ở đây thầy?
Mình quên mất, mình quên sửa cho tụi em. Hôm bữa là mình kết luận là gì ta? Bài 1 là tụi em không có trình bày đúng không? Đúng không?
Dạ đúng rồi.
Còn các còn lại là ok hết đúng không?
Dạ đúng
Đúng
rồi.
không?
Dạ,
Rồi để mình sửa lại, giờ mình sửa luôn.
dạ em cảm ơn thầy.
Dạ,
Mình quên
đúng là cái bài 1 em trình bày tất cả mấy cái số đó ở trong cái hình vân code luôn này, chứ không phải là
mình biết rồi, thì hôm bữa mình đã thống
thầy đã
nhất lại
nói
rồi
vậy.
đúng không?
Dạ rồi,
Rồi,
thầy
ok.
nói.
Mình sẽ sửa liền cho tụi em.
Dạ rồi, cảm ơn thầy.
So, do you have any more questions? Okay, I already fixed this. Okay. Okay, so if you don't have any more questions, we will the class dismissed now. Okay, thank you for your attendance today.